This is the second episode in a three-part series where we will be building an end-to-end state-of-the-art audio-to-text transcription service. In the first episode, we covered the core idea and the current state of the audio-to-text transcription market. In this episode, we'll be building out the Phonic Tonic website along with the backend infrastructure. We'll chat about how the production architecture works, following requests as they flow through it, and you'll get all the code too. Finally, in the third and final episode, we'll be checking out a launch checklist, exploring payment options, and working our way to a well-polished minimum viable product. Alright, so I already created the Phonic Tonic website and it's live. You can check it out by visiting phonictonic.com. Basically, you just enter your email, drag and drop your audio files, and then click submit. Behind the scenes, we're probing the uploaded files to make sure they're actually audio files, transcoding the audio files into an acceptable format for transcription, and finally transcribing the files into a human-readable format. In the future, there'll probably be some type of cost estimation and payment page after you click submit, but for right now I'm just showing you an itemized list of files you uploaded, and you can view the transcribed text once it's ready via this transcription link. Pretty neat, right? For right now, I'm only transcribing the first 30 seconds of any file that gets uploaded, just because since this is costing real money on my end, I sort of want to limit things while we're testing. I mentioned that you'll get all the code for how this actually works. Well, I just posted all the code up on my GitHub page and you can browse through it if you're interested. You'll find the web service, the transcoding worker, the transcribe worker, and our email notify worker code. So in here you'll also find the Docker files, the build.yaml files for automated deployments, along with the Kubernetes YAML files to describe how things should be deployed initially. I'd recommend watching episode 56 on Kubernetes, episode 58 on simple deployment pipelines, and episode 59 on RabbitMQ, as they all offer lots of supporting ideas and information that underpins this episode series. This code is still really rough. It's sort of hard for me to post this as I really like to have things super polished, but it's the reality of what a startup might actually look like. In fact, you'd probably be shocked at what most enterprise companies look like too. Things are barely running behind the scenes. There's lots of things that need fixing, and there's lots of work required for sysadmin and DevOps staff to get things into a stable and production-ready state, so it sort of fits with the theme we're going with. Down here, I listed a few issues that we need to fix. I intentionally did a bunch of bad things in the code that you'll likely run into in your daily work too. Things like hard-coding usernames, passwords, IP addresses, storage buckets, and project names. Don't worry, none of these are actually active, they're just for show. There's also no monitoring, logging, or alerting configured. So what I was thinking is that we can sort of create a bunch of new episodes over the next few weeks and actually work on correcting these rough spots. Let's jump over to the container ecomap for a second. So we've covered a few topics here already, but there's two major areas that we've not chatted about yet. They're logging and monitoring. So this sets the stage for a few episodes where we can instrument this Phonic Tonic application with things like metric monitoring using Prometheus and Grafana, application logging with Elk, and lots of alerting for when things go wrong. I wanted to create a few dashboards too. The cool thing here is that you'll actually get a real-life application to work with, and you get a peek behind the scenes and full access to everything. So it should be a really good learning tool. This sort of puts you in the shoes of someone starting at a new company where they have literally nothing but the app coded. We'll need to configure all the supporting DevOps systems around it. Alright, so you've seen the live demo, you have access to the code, and we have a pretty good idea of what needs to be improved down the road. So let's walk through how this application actually works behind the scenes. Let's flip over to some diagrams and go through it step by step. It's been my experience that sysadmins and DevOps folks are typically not coding customer-facing apps or anything like that, but we are heavily responsible for making them run smoothly and hitting uptime targets. So let's get a general sense of how things work under the hood, without going too heavy into the code. So a user shows up at our website hitting our web service. They enter their email and upload their files. We're flushing all this data into a SQL database for job tracking, uploading the audio files to a cloud storage bucket, and then we submit a bunch of tasks into a queue for processing. This might actually be a good time to review how the supporting infrastructure is configured. So we have the Phonic Tonic website that we looked at earlier, where you enter your email and upload your files. I've also coded in an admin page here. This can be useful for checking if jobs were actually submitted and things like that. This is disabled on the live version though. All this is running on a Kubernetes instance called Phonic Test, running on Google Cloud. We configured something similar in episode 56. Then under the Workloads tab here, we have our 4 services: the web service, the transcode worker, the transcribe worker, and finally the notify worker. I've shut all these workers off so that we can gradually enable them and watch how things flow through the queues as these workers action them. If I just enabled all these workers, jobs would execute too quickly for us to track step by step how things are flowing through the process. Talking about queues, I have a RabbitMQ server running too. You might want to watch episode 59 as a refresher on that. So we have our Kubernetes compute instances here. And by the way, I've just manually installed RabbitMQ. I was thinking that it might be kind of a cool episode idea for us to take a manually installed instance like this, containerize it, and then run it on a Kubernetes cluster. So we'll look at doing that in a future episode. So here's what the RabbitMQ admin interface looks like. You can see there's no tasks in the queues right now. But if we click over to the queues tab, you can see our queues are defined here. Also, once we upload some example audio files, you'll see these queues get populated, and tasks flow from queue to queue as the workers action them. Next up, we have a storage bucket, where we'll store the raw and transcoded audio files. This is sort of a staging area, where the web service can upload things, the transcoder can process them, etc. Let's just refresh the page to show there's nothing in here. Again, this will get populated down here with our audio files when we upload something in just a minute. Next, we have the MySQL server. This is running as a managed instance just because it's nice to have someone else look after it for you. You don't have to worry about all the replication, scheduling, backups, etc. But it does cost extra money. And here's what the database schema looks like. There's a jobs table for tracking high-level user jobs and the emails they belong to. This is pretty hacked together for now, but we'll flush it out down the road. Next, we have this tasks table. This is where I'm tracking things like file name, status, size, audio length, and the resulting transcript. My method for creating a database schema is pretty simple. Just write down on paper what data a user is going to input into your application. So things like email and all the metadata about the files they're going to be uploading. So we need to track things like the file name, size, etc. It sounds so simple, but it gives you a really good starting point. I typically write this on sticky notes and sort of group similar information together. And you can sort of get an early look at what a schema might look like. But it sort of doesn't show here as this is pretty easy and we're not tracking lots of data. Next up, we have our source repos along with the build triggers. You should totally check out episode 58 on simple deployment pipelines if you haven't already. Using this setup allows me to deploy code changes for each of these applications in around a minute. So that's a super quick tour of what the backend infrastructure looks like for phonictonic.com. And we covered key dependencies for our application, things like the SQL database, the storage bucket, and the RabbitMQ server. Using this type of worker queue system gives us a lot of operational scalability options too, in that we can scale things piece by piece on its own. Using containers and Kubernetes really allows us to offload a lot of the complexity of this too. We can easily scale up and down the worker counts too. All right, let's jump back to the diagrams for a second. So let's try and get the system into this state here, where we've entered our email, we've uploaded a few files, so that things get flushed into the database, we have some audio files stored in a storage bucket, and we have a few tasks in Rabbit queues. So let's go back to the website. I'll enter my email here. Then I'm going to click here and upload a few files. I just searched around for MP3 files online, and there's lots if you're looking for examples to try, particularly NASA recordings. All right, so we have our files uploaded. Let's submit the job. You can see we get this itemized results page. This is pulling data from the database about the job and all the submitted tasks. You can see things are stuck in this processing state, and that's because we don't have any of the backend workers running yet. Let's check the admin interface and see if our job has appeared. You can see we have our 3 files, and let's just click in for the details. Just a heads up, I like using these random unique identifiers for things like this, as I typically don't like trusting user data for storing things like file names. Also, having an admin interface like this really helps to debug things, as you can easily watch things as they're flowing through the system. Now let's check RabbitMQ. Great, you can see we have our 3 tasks sitting in the transcode queue. They're waiting here because there's no worker online to process them. I think I mentioned before that these cloud transcription services are super picky about the audio formats they accept. So say for example you upload a video and you want to get a text transcript of it. Well, I'll likely need to strip out the audio track from that video, then convert the audio into a format that the transcription service will accept. This is what this transcode worker does. It takes the user's uploaded files, strips out any audio tracks, and converts them into a WAV format. Let's check our storage bucket too to make sure the files we uploaded actually made it there. Great, so you can see we have our job unique identifier here. Then we have the 3 audio tasks sitting in the bucket. These match up with the messages we have sitting in RabbitMQ over here, waiting to be transcoded. All right, so hopefully this makes sense so far. Let's jump back to the diagrams and move on to the next stage of the process. So we have the transcode worker that fetches the audio files from the storage bucket, converts them into acceptable formats for us, and then saves them back to the storage bucket using a new name. Then we submit a task back into the queue for the audio to be transcribed. So let's jump back to the Cloud Console and turn on that transcode worker and see what happens. Just gonna click into the transcode worker here, then click Edit to modify the deployment YAML config file. I'm gonna update this replica value from 0 to 1. This is gonna start one instance of our transcode worker. Let's quickly jump over to the Rabbit interface and see what's happening. So you can see we have our 3 messages waiting in the queue to be processed. Then just like that, they moved over to the transcribe queue. So what happened here is that the transcode worker downloaded each audio file, converted it, uploaded a new version, and then added new tasks into the transcribe queue. It happened so quickly too, since these are small files. So let's check the storage bucket and refresh the view here to verify it's actually true. Great, so you can see we now have our raw files here in addition to these newly transcoded WAV files. Then tasks for these new WAV files were added into the Rabbit queue for the transcribe worker. What's cool about all this is that we could have lots of workers in each queue processing jobs, and this will allow us to really scale things up. Say for example that this application totally takes off and we're processing thousands of jobs. We could easily handle the workload with this type of architecture, but we'd need to beef things up, say for example adding redundancy for the database and RabbitMQ. We'd probably need to add database caching as well, and things like that, but this is a good start. Okay, let's flip back to the diagrams and check out how the transcription worker functions. The transcription service grabs a task out of the queue and submits a job into the cloud provider's transcription API, along with a config and a link to where this newly transcoded audio file is sitting in our cloud storage bucket. Then the worker waits for this transcription job to complete. It could take seconds or many minutes depending on how large the audio file is. Finally, it'll complete and it'll save the raw JSON results back to our cloud storage bucket and update the database with the final status and transcription data. Finally, we submit another task into the task worker queue to the notify worker to let the customer know that the job is finally complete. So let's head back to the Cloud Console and turn on the transcribe worker service. I'm just going to do the same thing here, edit the deployment and change the replicas from 0 to 1, and then save it. Now let's quickly check the queues in Rabbit. You can see we have our 3 tasks here. Cool, it looks like one was just picked up and is being processed. Let's head over to the storage bucket and refresh this a few times and see if we can catch the JSON file being uploaded here. Cool, you can see we have our new uploaded file here, and this is the raw JSON dump from the transcription API. Just going to open this in a new tab and we'll check that in a minute. I just want to head over to the Phonic Tonic website too, where we should see the status being updated to transcribing. Great, so it looks like it's working. While these audio files are being transcribed, let's check out the raw JSON dump that was uploaded to the cloud storage bucket. So this is all the raw data for things like the words spoken, adding punctuation, and lots of timing information when words start and stop. Then if we head back to the website, we should see the transcription links starting to appear now. Cool, it looks like it's working. Let's check one of these out. Great, so you can see the human readable version of the JSON object that was uploaded to the cloud storage bucket. Basically what I'm doing is parsing through the JSON objects and grabbing all the text. What I'd like to do down the road is add some sort of audio player so that you can play the audio and look at the transcript at the same time. Maybe add some sort of word highlighting as the audio plays so that you can follow along, especially since we have all that word timing information too. All right, let's head back to Kubernetes for a minute. These workers and queues are pretty much what makes this all possible, especially once you have lots of jobs flowing through here. This would be super hard to do without this type of architecture. But we're not done yet. We still need the notify events to be processed. But let's jump back to the diagrams for a minute. I never specifically called this out, but our transcription results page is continually checking the SQL database to see if things are finished. This allows the user to watch things in pretty much real time. This might be a good place for something like Redis to cache the results as we scale, since you could easily overload the database if lots of folks are checking this nonstop. Alright, so let's walk through the final step here, how notifications are sent. So once we start the notify worker, it will start grabbing tasks out of the Rabbit notify queue and hypothetically sending emails. Right now, I've disabled email notifications, and all the worker does is it'll grab a job off the queue and sleep for a few seconds before moving on to the next job. I did this since the website is wide open right now and I don't really want to allow the option of spamming people. So let's jump back to Kubernetes again, and I'm going to go into the notify worker deployment and edit the YAML file again, and change the replica from 0 to 1, then save it. Then let's flip over and watch what happens in the queue. Our notify worker should start grabbing messages from the queue, and hypothetically sending them out. Perfect, all messages are gone. So that's the end-to-end process of how this system actually works. This goes from uploaded audio files to human-readable text, although the audio is limited to the first 30 seconds for now. This typically happens really quickly too, but we were able to walk through it step by step by turning things on and off. This type of system also gives you lots of operational flexibility too. Say for example that you needed to do maintenance on a backend system. Hopefully you could just let jobs accumulate in a queue for a while, then turn things back on and watch the workers chew through the backlog. So that's pretty much it for this episode. I didn't want to get too heavy into the code, as typically we're most interested in the operational side of things. But all the source code's here if you want to have a look. Basically, I want to burn down this list of issues here, like hard-coded secrets, adding metrics collection, and things like that. But let's jump over to an editor for a minute and look at a few details. So there are things in here that we care about, things like the Docker files, the automated deployment scripts, and the Kubernetes Bootstrap YAML files. In an upcoming episode, we'll chat about secrets and environment variables in an attempt to remove a lot of this hard-coded stuff. You can see I've already done this in a few places. Stuff like this, where we have our database username and password and all types of connection strings in here. I guarantee you're going to run into this on your own too. As I mentioned before a few times, in the next few episodes, we'll really focus on logging, monitoring, alerting, and fixing a lot of this hard-coded stuff. For example, on the monitoring front, I really have no idea if this service is even working right now. There's no alerting set up. The queues could totally be filling up and the app could be broken. This is pretty common in the real world too. I'm sure there are things at your work that you look after that are not monitored too. This sort of seems to be a continual battle. I struggle with it too. So we'll look at some tools that can help. Alright, that's it for this episode. If you have any episode ideas or ways that you think I could improve the site, please let me know. Thanks for watching, and I'll see you next week. Bye.